Pangeos, a floating city or a pipe dream. Pangeos is not just a yacht. It's a mind-boggling concept of a floating city. Designed by Pierpaolo Lazzari, this Terayacht is envisioned as a colossal structure, capable of hosting up to 60,000 people. Key features and controversies. Immense scale. Pangeos is truly gigantic, dwarfing any existing vessel. Its size and complexity raise significant engineering challenges. Self-sufficiency. The concept includes various amenities, from hotels and shopping centers to parks and even airports, aiming for self-sustainability. Environmental impact. Critics argue that such a massive structure would have a detrimental effect on marine ecosystems and contribute to climate change. Feasibility. While the design is captivating, many experts question the practicality and economic viability of building such a colossal floating city. Essentially, Pangeos remains a concept at this stage. Its realization depends on overcoming immense technical, financial, and environmental hurdles. Renault Float, a glimpse into the future of transportation. The Renault Float is a groundbreaking concept car that won a Renault design competition. Designed by Yuchen Kai, it envisions a future where transportation is autonomous, electric, and radically different from today's vehicles. Key features of the Renault Float. Maglev technology. Instead of wheels, the float utilizes magnetic levitation, similar to high-speed trains. This allows for smoother rides and potentially higher speeds. Modular design. The float consists of individual, pod-like modules that can connect in various configurations to accommodate different numbers of passengers. Autonomous driving. The car is fully autonomous, allowing passengers to relax and focus on other activities. Electric power. The float is environmentally friendly, powered by electricity. Social interaction. The design encourages social interaction within the vehicle, with flexible seating arrangements and transparent walls. A vision of the future. The Renault Float represents a bold departure from traditional car design. It challenges our perception of personal transportation and explores the potential of technology to transform how we move. While it may seem like a distant concept, it offers a fascinating glimpse into a possible future where cars are more than just vehicles. They are living spaces, social hubs, and efficient modes of transport. Gyroscopic Transport, a vision of the future. Gyroscopic transport is a concept that envisions a revolutionary mode of transportation that utilizes gyroscopic technology to elevate vehicles above traditional road surfaces. This innovative approach aims to address the growing urban congestion crisis by creating a new level of traffic flow. How does it work? The core idea behind gyroscopic transport involves large, disc-shaped vehicles equipped with gyroscopes to maintain stability. These vehicles would operate on elevated platforms, allowing them to move freely over regular traffic. Gyroscopes. These spinning wheels provide stability and balance, enabling the vehicles to maintain their position even when encountering uneven surfaces or obstacles. Elevated platforms. The vehicles would travel on specially designed. The concept often includes the possibility of multiple layers of gyroscopic transport, maximizing the use of urban space. Potential benefits. Reduced traffic. The ability to move freely without traffic interruptions could lead to faster travel times and improved transportation efficiency. Environmental impact. Gyroscopic transport has the potential to be powered by renewable energy sources of greener future. Infrastructure. Building the necessary infrastructure for gyroscopic transport would be a massive undertaking, requiring substantial investment and planning. Safety. Ensuring the safety of both passengers and pedestrians is a critical concern that must be addressed through rigorous testing and development. With continued research and development, this vision of the future could become a reality. Urban air mobility, UAM, is a burgeoning concept that envisions a future where air travel becomes as commonplace as ground transportation. It involves the use of small, electric, vertical takeoff and landing (eVTOL) aircraft for transporting people and goods within urban areas. Key components of UAM. eVTOL aircraft. These are the core of UAM systems. They are designed to take off and land vertically, requiring less space than traditional aircraft. They are often electric-powered for environmental benefits and noise reduction. Infrastructure. This includes vertiports, which are essentially airports for eVTOLs, and air traffic management systems that can handle the increased air traffic. Regulations. A robust regulatory framework is essential for safe and efficient UAM operations. This includes rules for aircraft certification, pilot licensing, airspace management, and passenger safety. Benefits of UAM. Reduced traffic congestion. By moving transportation to the skies, UAM can alleviate ground traffic congestion. Increased mobility. UAM offers the potential for faster and more direct travel within cities. Environmental benefits. Electric-powered eVTOLs can reduce emissions compared to traditional aircraft. Economic growth. UAM can create new jobs and industries. Challenges. Safety. Ensuring the safety of passengers and pedestrians is paramount. Noise pollution. While electric propulsion reduces noise, it's still a concern. Flying trains. A dream becoming reality? While not yet a common sight, the concept of a flying train is no longer confined to the realm of science fiction. Existing concepts. Maglev trains. These trains use magnetic levitation to elevate themselves above the track, reducing friction and allowing for higher speeds. While they don't fly in the traditional sense, they give the illusion of floating. Suspended monorails. These trains run on a single elevated track, giving the appearance of flying, especially in urban environments. Hyperloop. This concept involves high-speed transportation systems in which pods travel through low-pressure tubes at incredible speeds. While not exactly flying, the idea of traveling through tubes at such high speeds pushes the boundaries of traditional transportation. Challenges and future possibilities. Developing a full-fledged flying train faces significant hurdles. Engineering challenges. Creating a vehicle capable of both ground and air travel requires immense engineering expertise. Infrastructure. Building tracks and airports compatible with such a vehicle would be costly and complex. Safety concerns. Ensuring passenger safety during takeoff, landing, and in-flight would be paramount. Economic viability. The initial investment and operational costs would be substantial. Despite these challenges, advancements in technology, particularly in electric propulsion and materials science, offer hope for future developments. Would you like to explore any of these concepts in more detail, or perhaps discuss the potential benefits and drawbacks of a flying train? Spacetrain is a proposed high-speed ground transportation system that aims to revolutionize travel. Inspired by the aerotrain concept, it's designed to be a much faster and more efficient alternative to traditional rail systems. Key features. Aerodynamic design. The Spacetrain is shaped to minimize air resistance, allowing it to reach high speeds. Air cushion technology. It utilizes air cushions for levitation, reducing friction and enabling smooth travel. Linear induction motors. Powerful linear induction motors propel the Spacetrain, ensuring rapid acceleration. Carbon fiber construction. The use of lightweight carbon fiber materials contributes to its speed and efficiency. Potential benefits. High speed. The Spacetrain is projected to reach speeds significantly higher than conventional trains. Reduced travel time. Shorter travel times between cities would be possible. Energy efficiency. Air cushion technology and aerodynamic design can contribute to lower energy consumption. Reduced environmental impact. With potential for electric propulsion, the Spacetrain could have a smaller carbon footprint. Challenges and future development. While the Spacetrain concept is promising, there are challenges to overcome. Infrastructure. Building specialized tracks and stations would require significant investment. Technology. Developing and refining the air cushion and propulsion systems is essential. Saudi Arabia's dream of the desert, a luxury train experience. Saudi Arabia is set to unveil its first luxury train, the Dream of the Desert, in late 2024. This opulent rail journey promises to redefine travel through the kingdom, offering passengers an unparalleled experience amidst stunning landscapes and rich cultural heritage. Key features of the Dream of the Desert. Luxurious accommodations. The train will feature 40 cabins, accommodating up to 80 passengers. Each cabin is designed to provide ultimate comfort and elegance. Culinary delights. A fine dining restaurant and lounge bar will cater to discerning palates, offering a delectable array of international and local cuisine. Enchanting itinerary. The train will traverse 1,239 kilometers, starting from Riyadh and passing through Al Qasim, Hale, the King Salman bin Abdulaziz Royal Natural Reserve in Al Juf, before reaching Al Khurayat. This journey will showcase the diverse beauty of Saudi Arabia. World-class service. Passengers can expect impeccable service and attention to detail throughout their journey. A glimpse into the future of luxury travel. The dream of the desert is poised to become a flagship project for Saudi Arabia's tourism industry. By combining the allure of the desert with the opulence of a luxury train, this initiative aims to attract discerning travelers from around the world. Would you like to know more about the specific routes, amenities, or booking information for the dream of the desert? Norway's underwater floating, a marvel of engineering. Norway is at the forefront of innovative infrastructure with its ambitious plan to build the world's first floating underwater tunnel. Why underwater floating tunnels? Norway's rugged coastline, characterized by deep fjords and harsh weather conditions, presents significant challenges for traditional transportation infrastructure. Bridges and conventional tunnels are often impractical or too expensive. That's where underwater floating tunnels come in. How do they work? These tunnels are essentially large concrete tubes submerged about 100 feet below the water's surface. They are held in place by a combination of buoyancy. The tunnels are designed to be slightly buoyant, helping them resist vertical forces. Tethers. Strong cables anchor the tunnels to the seabed, providing stability against horizontal forces. Benefits of floating underwater tunnels. Cost-effective. Compared to traditional tunnel or bridge construction, floating tunnels can be more economical. Environmentally friendly, they have a minimal impact on marine life. Resilient, designed to withstand harsh weather conditions. Efficient, offer a faster and more reliable transportation route compared to ferries. The Rogfast Link. One of the most prominent projects is the Rogfast Link, which will include a 1.7-kilometer floating tunnel as part of a larger road and tunnel system. This ambitious project is expected to significantly reduce travel time between Stavanger and the island of Averøy. Would you like to see some images or videos of these incredible engineering feats? Or perhaps you're interested in learning more about the challenges and innovations involved in building these structures. TransPod Hyperloop, a high-speed transportation system that can travel at speeds of up to 1,000 kilometers per hour. The system uses a network of tubes that create a low-pressure environment, allowing pods to travel at high speeds with minimal air resistance. The pods are propelled by linear induction motors, which use magnetic fields to create a force that pushes the pods forward. The system is being developed by a Canadian company called TransPod, which has been working on the technology for over 5 years. The company has already built a test track in British Columbia and is planning to build a commercial system between Calgary and Edmonton. The TransPod Hyperloop has the potential to revolutionize transportation by providing a fast, efficient, and environmentally friendly way to travel long distances. The system could be used to transport people and cargo and could help to reduce congestion on roads and highways. Hyundai at CES 2022, a focus on robotics and meta-mobility. Hyundai's presence at CES 2022 was a significant milestone in its journey towards becoming a global mobility provider. The company shifted its focus from traditional automobiles to explore the potential of robotics and its integration into the metaverse. Key highlights of Hyundai's CES 2022 showcase. Meta-mobility. Hyundai introduced the concept of meta-mobility, which combines the physical and virtual worlds. It envisions a future where robots not only provide physical mobility, but also serve as access points to the metaverse. Robotics. The company showcased a range of robotic solutions, including plug-and-drive (P&D) modules. These modular platforms can be attached to various devices, enabling mobility for objects and even creating mobile spaces. L7. a small, lightweight mobility platform designed for personal use in urban environments. MOBD, a small mobility platform with eccentric wheels, offering stability and maneuverability. Starship-Super Heavy, a new era of Earth-to-Earth travel? SpaceX's Starship-Super Heavy system is primarily designed for space exploration. However, its immense power and payload capacity have sparked discussions about its potential for revolutionizing Earth-to-Earth transportation. The idea is simple. Instead of using airplanes, we could potentially use Starship to travel between cities. Given its incredible speed and ability to carry large numbers of passengers, it could drastically reduce travel time speed. Starship could potentially travel at hypersonic speeds, making intercontinental travel much faster than current methods. Capacity. With its large size, Starship could carry a significant number of passengers and cargo in a single flight. Environmental impact. While the environmental impact of rocket launches is considerable, the potential for reusability and the reduction in traditional air travel could offer some environmental benefits. Challenges. Cost. The development and operation of Starship are incredibly expensive. To be economically viable for Earth-to-Earth travel, cost would need to be significantly reduced. Infrastructure. Starship would require specialized launch and landing facilities, which would be costly to build and maintain.